Hello, class. Welcome to the lecture on science and critical thinking. Today, we're going to look at how science works and why it's important. And we're also going to be looking at pseudosciences as well, and we're going to be doing a lot of examples. So let's roll. So why scientific reasoning? There are a lot of interesting ideas and services and products and just ideas in the world that sound really interesting and intriguing, but not all of them can be true. For example, is there a guy out there who really can talk to your deceased grandparents just by being around you? There's a TV show called Crossing Over with John Edward that specifically makes that claim. Is it true though? Is John Edward actually talking to your deceased aunt? Or is John Edward simply using cold reading techniques that are hundreds of years old and are not supernatural at all? Or what about the claim that if you wear magnets on your wrist, on your chest, or whatever, the magnets will cure health problems that medicine can't? So you want to cure your arthritis? Well, wear a magnetic bracelet, and that will solve your arthritis. Is that true? Should you put $300 down on a magnetic bracelet so you can cure your arthritis? Or is it all baloney? Well, with scientific reasoning, we can learn to test these kinds of ideas. Or even something as out there as the Bible code. Is there a hidden code inside the writing of the Bible that was able to predict past events? And we've just missed this code, and if we use this algorithm, we can discover all these things that have happened. Well, the idea of scientific reasoning is that we can systematically test ideas like these. As interesting as they sound, not all of them are going to be true. And the way of sifting between the true ideas and the false ideas is by having a systematic method of testing ideas. And science and scientific reasoning is all about teaching you how to use a systematic method to sift out the true from the false. So here's what scientific reasoning is. First off, it's a way of looking at the world. So science, of course, makes some assumptions about reality, and that is, what we can see, hear, touch, and taste, and feel, and measure is what technically exists. And as a way of looking at the world, it's a way of, therefore, having a method of obtaining knowledge. In this case, it's through controlled experimentation. If you're going to claim that a certain thing exists, a certain kind of energy exists, well, this energy, whatever it is, it has to have some kind of impact in the world for you to make this claim. Because if you say this energy exists, well, how do you know it exists? Usually it's through some kind of sense, right? It's through your physical, visual, auditory, or kinesthetic kind of sense. Well, then we should be able to test it using those senses. So science creates a method for obtaining knowledge where we can decide what is the appropriate way of testing this claim. And the method is systematic. Thirdly, the scientific reasoning is self-checking. So one of the things that science does a really good job of is testing its own ideas. One of the things that we have in science is the concept of peer review, and the fact that we have people who look at all of our different experiments and try to skeptically approach what we did to make sure it's of the highest quality. And when bad studies do get published, they immediately get withdrawn, or they get checked back, or they don't get published at all in the first place. Fourthly, scientific reasoning is constantly evolving. We're constantly improving our ideas and our theories. It's not like we just have one theory and it holds true all the time. We're constantly finding and challenging our ideas, but we're doing it with evidence. And whenever a new idea is proven to be superior to the other ideas, we change our theories. And lastly, scientific reasoning challenges wishful or erroneous thinking. The result of scientific reasoning is this. When we can test things empirically, when people make empirical claims, then what we can do is we can decide and we can challenge whether an idea is true or not based on our tests. And if the results or the data doesn't show or support what a person is saying, then we can dismiss the idea. And this will often allow us to challenge wishful or erroneous thinking. Now, there are 6 tests of scientific reasoning, and what we mean by test is, if you're going to make a scientific claim, it's going to have to pass these criteria. The first criteria is falsifiability, and the criteria states that the claim must pose a hypothesis that can be disproved. In other words, if you're going to make a claim, it has to be a claim that we can disprove. If you're going to say there's an energy in the world, for example, you're going to have to somehow propose it in a way where we can test or we can disprove whether this energy exists or not. So you'll have to clearly define what it is. What is this energy? What does it look like? How does it work? And then in what ways does it impact the world? And in what ways can we disprove whether this energy exists or not? The famous example is given by Carl Sagan. So Carl Sagan gives the example of the dragon in the garage. So suppose somebody said to you, there is a living, breathing dragon in my garage. The first question you might ask is, okay, well, let me see the dragon. Oh, well, the dragon is invisible, so you can't see him. Okay, a little strange, but there's other tests we can do. Well, let's throw paint on it, and then maybe the paint will, show a silhouette of a dragon. Well, the person says, the dragon actually doesn't have a physical body, it's a spirit. Okay. Well, then maybe we can put flour on the ground and the dragon will leave footprints. Oh, no, the dragon flies, so you can't test it on the ground. Okay, well, let's look for heat signatures. Can we see if there's any heat where the dragon breathes fire? Oh, no, the dragon doesn't actually breathe fire. So you can see where this becomes problematic. If you're going to say there's a dragon in your garage, but then every single test, you kind of move the goalpost to where it's like, well, but you can't test that, and it doesn't do this, and doesn't do that, and there's no real way to test it, it kind of becomes a meaningless claim. And then you kind of wonder, what does it mean to say there's a dragon in your garage when you can't see it, it doesn't move, it doesn't make any impacts in the environment, it doesn't leave a heat signature. So these kinds of claims that you can't disprove because no matter what test you use, the test isn't good enough, these are the kinds of claims where they're not really scientific claims anymore because they're not subject to any kind of disproval. Can you think of a claim or something that you've heard, in your own life that kind of sounds like this, where when you try to test the idea, they keep moving the goalpost, or there's no way to really disprove it because everything is, in some special circumstance? The second criteria is logic. And this criteria says that the claim must be logically sound in that its argument, 1, has all true premises, and 2, the conclusion follows the premises. Now, what this means is, number 1, the data that the argument rests upon needs to be true. And we learned about that in the first 2 weeks of the course, especially in logic and critical thinking. And then the conclusion has to follow the data. So the data has to be right, and then the conclusion that is drawn from the data also has to be right. Because you could be operating on real data or true data, but you can still draw the wrong conclusion from the true data. Let's look at an example. Alien crop circles, okay? So you probably have heard of these before. Supposedly, aliens are coming to Earth. They're traveling light years and distances across the galaxy with their advanced technology. And rather than talking to humans directly, what they do is they draw neat little circles in wheat fields across the world, and they're not very clear as to what they mean. And essentially they do that and then they leave, probably just to troll humanity, more than likely. And but there are these crop circles and aliens make them. Now, if we look at the argument made by people who say that these are made by aliens from far distant, planets with advanced technology, the argument usually goes something like this, okay? So crop circles are extremely complex and numerous. That's usually number 1. Human beings are incapable of such complexity on a grand scale, so that's their argument number 2. And then the conclusion, therefore, crop circles are made by extraterrestrials. Now, there's some interesting things here. The crop circles are pretty complex and numerous, I guess. You kind of look at this one here, there's some circles there and a little dot there. So, somebody got creative. But argument number 2 is interesting. Human beings are incapable of such complexity on a grand scale. And then, of course, there's the conclusion, therefore it must be made by extraterrestrials. Now we're going to get back to this one for a second, but let's just assume that this is true. Let's look at the third premise here. Therefore, crop circles are made by extraterrestrials. Now, we've learned the fallacy appeal to ignorance. Just because we don't know something doesn't necessarily mean my conclusion is right. So let's say we had no idea where this crop circle came from. It would be fallacious to say that it's necessarily extraterrestrials from another planet. We still haven't ruled out other possibilities. We still have to entertain the idea that it could be a person, it could have been an animal, it could have been the wind, it could have been a bad seedling thing going on there and it just got mistreated. So it's a bit of a hasty conclusion to say, therefore, it was aliens per se. But actually, it turns out that the second argument is wrong. That indeed humans are capable of making the circles. And in fact, there are two men right here who, when crop circles first started being discovered in the 1970s, or they became a big craze, there were two men who were hoaxing people and basically making crop circles in random parts of the world just because they thought it was funny. And they ended up coming out, and they even say, here's how we made the crop circles, and all it took was some plinths and some strings. So it turned out that humans were very well capable of making the crop circles, and two of the hoaxers themselves came out and explained how they made the crop circles. And in fact, this is a very beautifully done crop circle, and it was done by a human. We know for a fact because the person took credit for it and put the time in to make it. These are actually swallows here that they actually did, so it's a very pretty design. So we know that premise number two, that humans aren't capable of doing such a thing, is just false. We've seen that humans have done it, and in fact, there's people who even explain to you how exactly to do it. So these are the kinds of things where logic really does play a huge part, and that when you're going to make a scientific claim, it has to still be logically sound, even if the data might be true. The third criteria is comprehensiveness. And the idea here is that whatever theory you're going to put out, it must account for all of the pertinent data, not just select pieces. What this means is, if you're going to make a scientific claim, you can't just pick the data that works for you. You have to look at all of the data, and you have to take the whole context into situation, or the whole context of the situation into consideration before you make your grand claims. An example of this is the Newark Blackouts of 1965. What happened in the blackouts of 1965 was that in New York, they lost power in a big part of the city. And what was interesting was that after this all occurred, there were some articles that were written that talked about how the birth rate massively expanded 9 months after the blackout. So what some people were arguing was that, during the blackouts, a lot of people decided to make babies because there was nothing else to do. And so the whole thing was about how blackouts lead to more babies and all such things. But what was left out was that, the exact 9 months after the blackouts, it was actually a Monday and a Tuesday around that time. And usually when obstetricians are going to choose to induce labor, usually it's at the beginning of the week because people don't work on the weekends. So what was kind of left out in those articles is that the beginning of a week generally has higher birth rates than the end of the week. So if you count 9 months from the days of the blackout to the days that these births were taking place, the birth rate's always high during the beginning of the week, no matter what time of the year it is or what week it is. So it's one of those things where it sounded cool. It made for an interesting article, right? During the blackouts, there was a lot of baby making, but it turns out that there was really no correlation there because the birth rates were already high around that time anyways, because it was the beginning of the week, and it was all just a coincidence. So you have to look at all of the data. The fourth criteria for scientific claims is honesty, and that is the claims have to speak to the data, not popular opinion. Now this one's a very controversial one because by nature, there have been some scientific studies that have not been politically correct and have sparked some controversy. And it's kind of hard sometimes to put our own bias aside when we review scientific studies because we want the world to be a certain way. But the idea of a good scientific claim is that it's going to stick to the data and it's not going to cave into popular opinion or public pressure. Now, this is easier said than done when you're a scientist, of course, because you're very dependent upon society for a lot of things, and this is a very difficult thing to do. But what we don't do is we don't modify science. We don't modify findings just to make it politically popular. An example of this happening was when Vandal and Corasaniti did a study of the effects of childcare, the effects of kids going to daycare as opposed to kids who spend more time with their parents. And what they found was that kids who go to daycare had negative effects in terms of their cognitive abilities, their SAT scores, and even their behavior ratings by teachers and parents. So the authors tried to get this study published, but they faced a lot of heat and a lot of resistance because a lot of the people that reviewed these kinds of articles may be working parents who put their kids in daycare, and who wants to be told that, hey, you're negatively affecting your kids' psychological outcomes by putting them in daycare. So they faced some pressure, and it was difficult, but they had to stick to the data. And they said, look, the data says this, and this is what we have to do. So eventually they did get published, but you can see how it can be very difficult sometimes, where saying something that's not popular is still your job if it's backed up by the data of science. Now, if you do have your kids in daycare, because some of you might be working parents, don't fret, because one of the things about social science and psychological claims in general is that they're usually complicated. It's not a simple daycare is bad. It's more like there's certain factors that come into play, how many hours, and depends on age and how often you spend time with them on the weekends, and there's all kinds of complexities there. But the idea of getting this study published just kind of shows how good science is going to be honest. It's not going to say what's politically popular. It's not going to change or modify its claims to be more marketable. It's going to stick to the data. The fifth criteria has to do with replicability. And that is, whatever claim you're making, it should be based on consistent results observed in multiple experiments. And what we mean here is, if you're going to say, I can predict the future because I did it yesterday with my sister, then before we can really accept that claim, we need to see you do it again. And we need to see you do it multiple times, because maybe you got lucky the first time. And if you can't do it here, then how do we know you can do it there? That kind of thing. So we have to be able to replicate whatever the claims are and be able to do multiple experiments so multiple people can see for themselves. Because it's easy for one person to do an experiment and to say one thing, but if 5 people do the same experiment and they see something different, then we can know that it's possibly the one person's error in judgment, or there was a flaw in the study, or there's something that the original researcher missed. So we have to have replicability. We have to see multiple experiments. And if you're going to claim you're psychic, you got to be able to do it multiple times, and you got to be able to do it in controlled settings as well, as we'll see in our next example. So some of you might have heard this story, the story of Clever Hans. So Clever Hans was a horse, and one of the things that made the horse interesting was that Clever Hans could supposedly do math. So what would happen is Hans's trainer would give Clever Hans a math problem, and what Clever would do is Clever would tap his hoof on the platform however many times, up to the number of the answer. So if you said, Clever, what's 7 times 4? Clever would tap his hoofs up to 28 and then stop. And so, this attracted a lot of attention. Of course, you get on the show and you have a horse that can do math. And just think about all the psychological implications this could have if it turns out horses can do abstract math. Well, somebody finally decided to test this horse for real. And what ended up happening was that it was found that Clever Hans could not do math when the individual posing the problem didn't know the right answer, and when the individual posing the problem was not in clear view of Clever Hans. So here's what was discovered after some real controlled experimentation with the horse. When Clever was being done or doing his math in shows, generally the person who was asking the questions was in clear view of Clever Hans and knew the answer. So what Clever Hans would do is actually, as he started hitting the tapping on the platform, you as the person asking the question, of course, you're amazed that a horse is doing math, and Clever Hans would just read your nonverbals, and as you got closer to the answer, he would notice that he might tilt your head a little bit, or you might smile, you might get excited. So Clever would just stop when you think he got when you're giving them the right signals to say, yeah, you got the right answer. This is amazing. So what we really discovered then was that Clever Hans, if there was nobody around, or if he couldn't see the person, and if the person didn't know the answer, Clever couldn't do math. Like Clever would either not tap the hoof at all, or tap it too many times, or get it wrong entirely. So that goes on to say that horses can't do math, but horses are very good experts of nonverbal communication. The last criteria is sufficiency, and that means that the claim must be backed by enough evidence. And I'm gonna underline this because this is important. There has to be enough evidence to warrant belief. And what that means is that the burden of proof is on the claimants, number one. So if somebody is going to claim that a new medical treatment will solve all your problems, the burden is not on you to disprove that claim. The burden of proof is on them to support that claim. Or if somebody's going to say that alien abductions are happening, they need to prove that the aliens are coming and that they're picking up people and they are actually aliens and people aren't just being delusional, or people aren't watching too many movies. The burden of proof is on them. Secondly, that extraordinary claims require extraordinary evidence. So the bigger and more vast the theory is, the more evidence you're going to need to support that theory. So, these grand conspiracy theories, which we'll cover probably in another lecture or two, these really massive ones that involve like the one world government and all those things, those require a lot of evidence because there's so many people involved in these conspiracies or in these theories that you're going to need a lot of support for that. And the big thing is that evidence based on authority is inadequate. So you can't just say, well, because this person said so, then, this is why we can believe it. Or this person who worked at Area 51 said this, therefore we can believe it. We have to have enough evidence that's outside of just one or two or just, these anecdotal pieces of stories. We got to have something that's systematic. An example of inadequate evidence is, of course, UFO sightings. So, you probably have seen these on TV or you've seen it on the internet, interesting little light fixture things in the air and people saying, oh, look, these must be aliens. Okay. But, we have to make sure that the claims are sufficient. So, for example, what else could these lights be? Well, number one, it could just be a fraud or Photoshop picture. Now, I just did a Google Images search, so, but, it's very possible that somebody Photoshopped these. We've seen and we've heard of people making Photoshop photos of pretty much anything, and who knows if this is maybe just one of those as well. It could be a conventional or unconventional military aircraft. So, the military tests all kinds of airplanes and drones and all these kinds of flying objects. It may not be in their interest to always identify an interesting unidentified flying object because we don't want to take credit for it because, you have to keep things secret. Could be high altitude balloons, optical mirages, lenticular clouds, meteors. Those are all things that, make lights and shine and move. They could be satellites. They could be satellites or nose cones or rocket boosters re-entering the atmosphere. So there's a lot of very plausible explanations for what, these interesting lights in the sky are. And, more times than not, it's turned out to be one of these upon further investigation. And especially with the rise of the internet and Photoshop, I mean, this is a very common thing now. People Photoshop things and then they try to put on the internet to get hits or to get likes or whatever. So you have to be very careful about things that you see and photos that you see. But always remember, the burden of proof is on the claimant. And always remember, just because we don't know what it is doesn't necessarily mean it's aliens. Or just because we don't know what it is doesn't necessarily mean that what you claim it is right. You have to rule out all the other possibilities, and you have to make a positive case for why it is the thing that you claim it is. Otherwise, once again, appeal to ignorance. Now, a major principle of scientific thinking is Occam's razor. Now, you might have heard this before, but there's two ways of putting it. When there are two explanations of an occurrence, the simpler one is usually right. So, when you have those interesting floating lights, okay, one explanation could be it's a Photoshop photo, or it's a, if it's something in real life and you actually see a light. Maybe it's a government plane, right? An Air Force plane, a new technology that they're exploring. That's a much more simpler than there's some alien race out there that lives multiple light years away that comes to Earth, flies around, then goes back, but never does anything. Okay? So, there's explanations that are simpler, that make more sense. And so usually we prefer the simpler one. The other way of putting it, though, is the more assumptions that you have to make, the more unlikely the explanation is. So the more premises there are, and the more assumptions that you have to make to get to the conclusion, the less likely it's going to be true, because one of those assumptions is probably going to be wrong. Okay? So that's Occam's razor. The simplest explanation is probably the right one, or the most likely explanation is probably the right one. Now, there's 10 signs of a pseudoscience that I want to discuss really quickly. Number one, a pseudoscience will have the outward appearance of a science. What we mean is that often pseudosciences will have scientific terms. They might even they'll use physics terms, they'll use biology terms, they'll use medical terms, and it just goes beyond terminology. They might have degrees. So you might have somebody who has a degree in homeopathy, right? And so I'm certified by the National Homeopathy Practitioners, or I'm part of the National Association of Psychics, and here's my certification in ESP, psychic powers. And they may even have professional development seminars. They might have even a trade journal, okay? So it looks like a science, but it isn't, okay? They take some of the ideas of science, but it's not based on any scientific claims. Another issue is there's an absence of skeptical peer review, and the key word is skeptical. So yes, some pseudoscience organizations, certifications, medical providers, psychics, you name it, some of them have trade journals, and even there is a peer review for the trade journals where people can publish research. But the problem is it's not skeptical peer review. Everyone's very sympathetic to the field as a whole. Nobody challenges the basic tenets of the field, and it's just kind of like, well, this looks good for our journal, let's take it. Thirdly, there's reliance on personal experience. So let's go back to the magnet medical treatment. If you go to a magnet selling website, you'll probably have a lot of testimonials like, this worked for me for this, and this worked for me for that, and I had arthritis and this worked for me. But you won't see any mention of specific scientific studies that are published in a non-skeptical journal, okay? So the reliance is, we'll look at all these personal testimonies and see it works because it said it worked for these people. But one thing we'll learn when we do, in one of the upcoming weeks, we'll talk about how, the placebo effect and, effects like those can be misleading. Evasion of risky tests is number 4. What we mean here is that the science or the field does not do tests that could directly disprove it. Like either because they say that their field is not testable. So, psychics, you can't test psychics because when skeptics are around, the energy that they put out ruins the psychic energy or something like that. So the evasion of risky tests, the unwillingness to have tests that directly can determine whether they're right or not, or by changing the goalposts or whatever, not making unfalsifiable claims, that's a sign of a pseudoscience. 5th, retreats to the supernatural. So maybe, with the magnets, they might say, well, we can't prove that the magnets work, or we can't prove the energy. You can't see the energy that the magnets put out because it's a supernatural energy and there's no way of measuring it. So there's no way to prove the magnets work scientifically because you can't measure supernatural energy. So, but it works, ask the testimony of people here, testimony says it works. So what will happen is people, or the science or the pseudoscience, will use supernatural excuses to cover any issues that they have. There's also the mantra of holism, and what this is referring to is nowadays, especially with a lot of alternative medicines and such, they talk about things being holistic, like we treat the whole body, we treat the whole person. But one of the problems with that is, one thing you learn in real science is that everything is specialized in science because every little part of the world is complicated. psychology is complicated. That's why you have to get a degree in psychology and you have to study, and then you specialize within that on cognitive psychology, neuropsychology, social psychology, and all that. The heart is complicated. So even if you have a medical degree, you have to become a cardiologist to really understand the heart. So to say that I can be an expert in both the heart and psychology all at the same time, and also the environment and all the parts of the body, is just not possible. Nobody can go to school for that long. So you have to be careful with this idea of holistic, because you have to ask, what factors are you considering when you're saying, I'm considering the psychological life of someone, the biological life of someone, their physical attributes, and all of that. There has to be factors that you're drawing from each. And if it's not clear what factors you're drawing, it becomes problematic. There's no way to test whether holism actually works. Another issue is tolerance of inconsistencies. And this is seen, for example, in astrology. So some astrologers base their astrology on the seasons. But this poses a problem because if you're in the southern hemisphere, for example, the seasons come in a different order. So some will reverse their seasons if they live in the southern hemisphere. But if you're in the northern hemisphere, the seasons go in a different order. So if you're an astrologer, which one is right? Do you go off the northern hemisphere seasons or do you go off the southern hemisphere seasons? So you have some that go in one and others that go in the other. And that's a bit of a problem because that's a logical contradiction. That's a huge inconsistency in astrology. Which hemisphere do you go by when you decide which astrology to use for the seasons? So these are the kinds of inconsistencies that if you're not dealing with these, if the field doesn't try to solve this in any way, that's a huge red flag. Number 8, this is appeals to authority. So essentially, if the field relies upon one person making claims or believing in practitioners and just saying, well, because this person said it and this person's really smart or this person founded the field and they knew what they were talking about, so we just believe this person because they are the prophet and they are the ones who the knowledge has been handed down from. But there isn't a lot of like, here are some studies that have been done and here's what the consensus seems to be, or here's what the studies show for this and that. Then that's the difference between a pseudoscience and a regular science. A regular science will have studies done by third parties. It's not all vested in just one person's beliefs. It's spread out among people. Versus a pseudoscience, it might just be one or two practitioners or founders of the field or whoever, and everyone just kind of repeats what the founder said. Okay? Thirdly, or second to lastly, is promising the impossible. Pseudoscience often profits by making these very grandiose claims, like you can increase your lifespan, or we're going to cure cancer inside of you, and you'll live longer, and you'll live healthier, and you won't age as quickly, and all this stuff. And so the problem is just that these are very complex processes that, aging is not something we can stop. There's no peer-reviewed scientific study that has shown that aging can be reversed or stopped entirely. Now you've probably heard of like the wine studies that like, oh, well, wine can kind of have anti-aging effects, but we still age, but it's just much slower. So the idea is that a pseudoscience will attract people by making very grandiose claims and then not really delivering on those claims by, using practices that aren't supported by science. And then, of course, then when you say, well, but I'm doing this practice, but I'm not noticing results. Well, that's just because, it's invisible or it's energy and you're not feeling it yet, that kind of thing. So you can see how you get caught in a web within a pseudoscience because you get this grandiose claim, but then like as you start to pursue the claim, you're given all these runarounds about why the thing isn't working. So either you just believe it or eventually you come to your senses and realize, wait, this is all a hoax. And then, you leave the pseudoscience. Sounds like a cult. In some ways it is. And then lastly, you have a stagnation. So one of the things about pseudoscience is that the field doesn't evolve at all. With science, regular science or traditional or real science, however you ever want to phrase it, ideas are constantly being challenged. The field grows, it progresses. Old theories get discarded. Useless theories get discarded. New theories get adopted. and it's constantly challenging itself. Remember, there's skeptical peer review. People are constantly looking for what's wrong with the status quo and then trying to figure out how to improve it. With pseudoscience, there isn't a lot of progress on that front. In fact, pseudoscience often prides itself on this is ancient wisdom that's been around for thousands of years, and we just forgot the ancient wisdom. And so if we just go back to the ancient wisdom, everything will be good. We don't need to study anymore because the ancient people from 3,000 years ago knew what the right answer the whole time. Okay, so this idea of stagnation, when it's prized as being something good, and and there's not a lot of studies and people working to challenge ideas and to improve them, that's also a red flag. And of course, you have to be skeptical of ancient wisdom because the average human life expectancy is doubled within the 20th century. So why would people who had half the lifespan of us 3,000 years ago suddenly know everything about health? So these are the kinds of things you have to be thinking about when you're critical thinking. And at the end of the day, the conclusion is prove it. If I had to summarize this lecture in 2 words, it's prove it. If you're going to make a claim about anything in the world, anything external, anything that involves the senses, you got to be able to prove it. If you feel something, well then prove it. Prove to us how you feel it and how we can feel it as well. Okay? If you're going to say there's something exists, prove that it exists. But the big thing is, science is not just a collection of facts. Science is a way of thinking. It's a way of challenging ideas, and it's a process. And if you can use this process, you can save yourself from being deceived a lot. And you can save yourself a lot of money because, man, there's a lot of marketing out there for products that just are pseudoscience.